Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
He has been an intern twice and has worked in between that, and he now is still hanging on and helping us out with a lot of tasks on Code Hunt. And in particular, his main thing has always been what he calls the hint system, but he has a vast knowledge of what goes on as well. So we can fire all sorts of questions at him. Where you go, Daniel.
Yeah, so I'm going to be talking about the hint system, which is currently in Code Hunt, which is not fully operational at the moment, but was in the past. So Code Hunt, well, okay, we already know what Code Hunt looks like. Go to a level, send code. It gives you some feedback, which is already a sort of hint that it's telling you, okay, some paths are correct. Here's some values. Here's some things that are incorrect. Here's some values, which is something that would probably normally be considered a hint in another, and if you were doing like homework or something. And it changes in different ways. So. Something wrong with the lights? Okay. So for more complicated puzzles, you probably aren't going to be able to look at these numbers and immediately figure out what this is actually computing. For the very first puzzle, you can just glance at it and it's pretty obvious. But here we want to be able to give some additional feedback about just something to nudge you in the right direction when you're totally lost, and do something like say, oh, one of the expected results was 40,320. Let's try returning that and see if this is close to the solution. The answer is that's nothing to do with the solution. It's completely misleading. But there's other things we might be able to tell the person, like, the solution involves a loop. You should probably stop letting stuff that doesn't contain a loop. This probably should have been a giveaway that this problem is in sector 3, which is titled loops. But maybe you need an additional hint. These hints also don't know about the sector names. But also we can sometimes be more precise and say, oh, this line is where your problem is. Change just that line. The rest of it's OK, which is one way of saying that you're close to a solution. This is a sort of, as we had been discussing with the last talk, this is a syntactic way of saying that you're close to a solution, which is very different from the sort of more semantic way we were talking about earlier. And the other thing is, the other version of this hint is, maybe you want a less than or equal to in this puzzle. And putting in the less than or equal to on line 4 solves the puzzle. I'm giving away a solution now. So it presented these few different types of hints that the system can produce. They look at line 4 to capture the code, which I call line hints. And then there's positive recommendation hints, which means try some construct. In this case, you may find a loop useful on this level. And lastly, negative recommendation hints of the expression 40,320 is rarely used to solve this level. Probably try something different. So I'm going to talk about how I generate all of these, and unfortunately, and a little bit of data on how useful they are. So first, the line hints are sort of my primary research is on program synthesis, and the line hints work by applying my program synthesis research to Code Hunt. We have the solution as an oracle of what the actual solution is, and we want to start from the student's code as the basis for what we're synthesizing from, and try to mutate it so that it is a solution. In some sense, sort of the programmatic version of what the student is doing, except we're only guided by the test cases from PECs and not by any amount of insight that the student might have, which my program synthesis technique is not attempting to be AI and intuit the solution in any way. There's an important point that this is only a meaningful thing to do when we're actually syntactically close to a solution. Because if I tell you that in your 10-line program, you should probably change lines 1 through 10, you're going to say, okay, that tells me nothing, and it's a little discouraging. It's not a useful hint. In that case, you'd have to find some other way to nudge the student towards a solution. Of course, if they are completely way off, then that's also probably a sign that you want to give them a hint. So, the question, is there actually a usefulness of this? That if the users almost got it, then they already know what's going on, right? They probably don't need a hint. So I did run an experiment, which I'll show more data for later. But here, the students that actually saw a hint on a puzzle, so we're figuring out my measure of whether they're close to a solution is whether or not we were able to actually generate a hint. And we can either show them the hint or not show them the hint. We say that eventually people usually solve the puzzle if they got close enough that I was able to generate a hint. But if they were shown the hint, they solved it a lot faster. So this is showing that they found the hint helpful, and that from a pedagogical standpoint, it's still not obvious that the hints are helping them learn. But it's hard to get that information out of the data. But this is showing that at least that just because the student is close, they might not necessarily realize they're close. Sorry?
Does this mean that whatever hint was given, all these 83% people used that hint, or did they do something else?
I did not actually check that in this data, mostly because getting these numbers is very simple, and figuring out whether they actually use the hint is much more difficult. Did you have a question on that? Oh, no, okay. So yeah, they might have solved it a completely different way. There's also the point that, sorry, yes? If you're very close to a solution, the hint generator actually often generates 4 or 5 different small changes. It chooses the one that's smallest, but it's still, the fact that it might, the one it gave might be one small change, might be a 1-character change, and there might be a 2-character change on a different line. In which case, it's not really meaningful to say, did the student use the hint or not? Sorry?
So these numbers differ based on the problem, because this problem seems to be really easy, like 98% solve it.
98% of the people who got close enough that my synthesizer was able to find a single line change.
Then the question is, did you try these measurements on easy and difficult problems?
I did not distinguish which problems to look at, but it would be interesting to see if splitting it out by problem change this.
The difficulty, right? It's perceived or subjective.
Yeah. So I think I sort of mixed them together because this was a moderately small data set, so separating by problem would have given me fairly few attempts. But yeah, if I had enough data, then that would be an interesting thing to look at to see if that. Because once again, the hints are probably more useful on harder platforms, which is presumably what you were getting at. So what is this magic? So, complicated diagram time. So, this is the flowchart version of what code hunt looks like. There's a cycle where PAX generates test cases, the user modifies their program, they ask if they're done or not. Either PAX gives them new test cases, and they loop, or they won the level and they're done. We change a few boxes on this diagram, then we have something that looks like the flowchart for my synthesizer, where the synthesizer is designed to work on some iterative process where it handles one new test case at a time, modifying the program and iterating on that. So basically, when I designed the synthesizer, one of the things we did with it is sort of like just for silly random thing to try to run it on. We landed on PEX for fun, and using some somewhat contrived metrics, we showed that on the subset of puzzles we used, it was able to complete the puzzles in approximately the same time as the students on PEX for fun. Where this is sort of quality line where the bottom is how long it took the average student to solve a puzzle, and the y-axis is how long it took the synthesizer to solve the puzzle. Hand wavy, hand wavy, hand wavy. We're like, if we're actually about as good at students at solving these simple coding problems, maybe we can give them hints on them. So, yeah, I had that slide for a reason. Particularly, in order to generate the hints, we mine all the solutions from the students, including the reference solution, for what functions and operators, etc., that it actually uses, and the synthesizer uses that set of functions for what it's trying to write into the program, and then as to where to modify the program, it just enumerates every sub-expression of the program and enumerates every new expression it can build out of the pieces of the program and the pieces of all the other solutions. And it does some intelligent things when enumerating them, but that's essentially what the algorithm is. So if we had this example that I had shown before, then it's just going to, it will have all of the operators like less than or equal to and probably some other things that were used in all of the solutions. It will go through every sub-expression and consider replacing it with a bunch of different things until it hits upon something that passes all of the test cases. Yeah. As I said, we do try to build expressions out of what the user is already using, but we also try to supplement that in case there was some expressions that they needed out of some other solutions. Particularly, like, I guess before there was the example where in the previous talk someone had written x minus y when the solution was x plus y. The plus has to come from somewhere. Okay. So there's a few, as I had mentioned before, it's going to come up with multiple solutions. Here there's a few different solutions that all have sort of an AST difference of replacing one AST node with another AST node. We can multiply by, basically we want to multiply by upper bound, but there's a few different ways to do it. We could do it there, we could do it there, we could change that there. And to the computer, these, at first glance, looking at trees, these all look like basically the same amount of difference change. But to a human, this probably looks like a much smaller change because he only changed one character. So I actually get multiple solutions out of the algorithm and take the one with the lowest number of lowest edit distance just by characters. Yeah. This slows down the algorithm a little bit, but it's not a big deal. So, sort of larger problem is that, especially if we're looking at the attempts, but balanced by the number of attempts in the APCS universe, the first sector to basically everything is one line. So if I tell you that the single line of your program has a problem, then I have given you absolutely no information. You already knew that. So since obviously what the synthesizer is actually generating is a diff of some subtree of your program, we can try to process and give that as a bit more information, but there's the balance of between simply giving away the solution and giving a hint. Said, as I comment here, one way is the user could add new lines to add a little more detail. What we actually do is give hints like this, say, oh, look at numbers on line 4 to try to say, oh, this is what you should replace to give a focus more precise than the line when there's only one line to talk about. Yeah. So that ends what I had to say about how the line hints work. If there were any questions on that section. Okay. So the other type of hints I have, which is a more or less completely separate hint system, which is almost entirely unrelated, other than sharing some of the parsing code, is the recommendation hint. As I said before, you have both positive and negative recommendation hints of you should add something or you are using something which is a terrible idea, don't do it. We generate these hints via a relatively simple mechanism of just looking at every single attempt and summarizing what structures were used in each one, and then doing some statistics on how common the structures were in solutions versus non-solutions.
For the second one, how to interpret this hint? It's like, it's rarely used in your player code, or it's rarely used among all the players to solve this level. What does that mean?
So I'm just trying to the wording was trying to avoid saying, oh, don't do it, this can't work, because it's possible that there are solutions that use it, and it's just trying to suggest that this probably shouldn't be done. As to the semantics of how it actually decides to generate that hint, it looks for expressions that are used by enough users to be statistically significant, but are not used by those users in their solutions. So that's what the statistics actually mean. I'm not sure if I actually answered your question. Okay. Yeah. So sorry here.
How rich is the family of the concepts that they can offer, like loops, branches?
So I wrote down a list of like 10 or 15 concepts like loops, if statements, and stuff like that. And then any expression is also a available concept. That's how it came up with 40,320. That's not hard-coded. That's just, it's an expression.
Yeah, but there's other thing about the concepts are more interesting, because they're predefined, right?
Yeah, so I just predefined a few of them that I thought of. They were fairly arbitrary, and maybe there was better ones.
But do concepts correspond to the construct law, or not necessary?
They're syntactic, so I think I I think I might have included recursion as a concept. Those nested loops is one of them. So there's a few things that are not just, this is a syntax item in your program, but they're approximately that level of complexity. I sort of wasn't really sure what else to put in there, and if other ideas are welcome. I can find a list somewhere in the source code. This is not documented. So the algorithm is we count users in a solution. We count users who use it but not in a solution, and we prefer telling people to not use things that they are using than to use things that they're not using, because based on the general concept that saying you should use this thing that you haven't thought of is sort of giving a stronger hint to someone, because that's something that because that's introducing a new concept to their awareness, as opposed to saying this thing you're doing right now is a bad idea, which is sort of giving less away to them. I feel that was sort of my intuition. Once again, this is hand wavy and has no actual data behind it. So other opinions are welcome. So to try to get some idea of how useful these hints are, this talk was way short. Ran an evaluation which had 3 conditions. For some of the users, we just always showed them hints. For some of the users, we switched off which puzzles we showed them hints. And for some of the users, we never showed them hints. So let's just compare. And I forgot to change that table. So down on a 2-day period after the user set. So here we have 3 different lines showing how many levels a user won, where the blue line is the people in the always hint condition, the green line is the people in the sometimes hint condition, and the red line is the people in the never hint condition, where the line being at a given point means that that proportion of users got through at least that many levels. So you can see that the never hint line is lower than the other 2 lines by a little bit, so they didn't continue playing as long. So they were at least somewhat less engaged in the game, and the other 2 are about equal on this metric. I'm not sure how much we can actually get out of this. Somewhat more interesting is how long the players played. This is also a cumulative graph of showing what proportion number of players played for at least some number of hours, where a number of hours played is defined by time of last puzzle submission minus time of first puzzle submission. I assume they didn't play for 48 hours straight, but I didn't actually check for that in my data. This interestingly shows that the people in the sometimes hint condition played notably more than the people in the always hint, who also played more than the people in the never hint. So it seems to show that the hints do in fact make the game somewhat more engaging. That we have a difference of 1/3 of the people in the sometimes hint condition were still playing after 2 days, as opposed to 1/10 of the people in the never hint condition. Since we had been talking about distance from the distance from the solution related to what hints we can give. This is an attempt to try to measure how well my hint system can give hints for a given distance from the solution. This is a very rough syntactic measure of distance of solution, in that I have merely done syntactic edit distance to the nearest known solution. By syntactic, I mean actual character by character Levenshtein edit distance, and bucketed the numbers. The first two colors are the line hints. The first blue color is the line hints where the answer was a single line, so the precise. So it had to say like numbers on that line or something like that. The next color was where it could actually specify a line. The yellow section is hints where it said some concept or expression was unhelpful and should not be used. The blue section is where it recommended some new concept, and the purple section is where it wasn't able to produce a hint at all. I'm not sure how informative this graph actually is. I just threw it together this morning. Yeah. I guess, yes.
Daniel, so your largest bar are hints you regard as unhelpful.
No, it's not that I think the hint is unhelpful. The hint is telling the user that something they're doing is unhelpful.
Oh, okay.
And it's the hint style of this expression is unhelpful, don't use it.
Right.
Possibly poorly labeled in my graph. And I'm not sure if this is a more informative way, but here's the stacked bar graph version of this, so we can look at the proportion, ignoring the amount of each. There's sort of like, basically the point of trying to look at this is trying to argue that I expect, this line to go down because if I'm generating generating the line hints by syntactic similarity, then I expect if the syntactic similarity decreases, then I'm going to be less able to generate those hints, which is possibly verified by this graph. Not sure. We also see that as the solutions are way off, then the system is less able to produce anything meaningful at all. That's the purple sections are getting larger at the top. Which one?
It's a bit better again.
I'm assuming that's just because there's little enough data that it's not meaningful, that it's just error, but I will have to look into it. As this graph was made this morning, so I haven't delved into this data that much. And that was actually the end of my presentation, which was running a bit short. If you have any questions or wanted to delve deeper into anything, then.
Kind of related to what William talked about in terms of problem on progress indicator or behavior similarities measurement. I mean, hint generation is another very important problem. Based on our experience with working on the previous problem, like progress indicator, one barrier for us to really make research progress is on the ground truth. So I think here we would have similar problems. So I think like some of these graphs are kind of a somewhat indirect measurement on the quality of the hints.
Yeah.
Or could say it direct, but it's just like, I mean, and I'm thinking about whether there could be some dedicated efforts, more like building up ground truth, for example, as a human tutor, right? If we want to help students or help players in really trying to make progress, what kind of hint would we give, right? And then when you have this data, then you could call for a more different kind of variety of solutions.
So for that type of ground hint, I believe it was code.org that was soliciting that type of hint. It was one of those learning websites was asking educators to say, oh, in this situation, write down. They were crowdsourcing. They were doing basically hint generation by crowdsourcing, and trying to.
Could something similar, I mean, be done here? I mean, because here it's a little bit reverse engineering, especially talk about, I mean, the coding tools. I mean, without explicit requirements, right? It's different from like you have a particular explicit requirement given to student, and then the student struggle, couldn't get it done, and then you give guidance. It's different kind of a guidance, I would say.
Yeah, I mean, we also have had sort of floated the idea of, I mean, I sort of call these personalized hints because they're based on what the student is actually listing as their code. So in a fairly strong sense, the line hints are more personalized than the recommendation hints. But you could imagine being less personalized of, oh, here's just a general hint that anyone on this level might want to see if they were struggling. And you could imagine crowdsourcing those. Of course, on that level, the internet sort of does that automatically by people writing blog posts about or having comment threads, which you'll find if you Google questions about Code Hunt. But yeah, I guess I haven't thought too hard about what the ground truth of what the best possible hint would be, partially because I'm not an educator. Sorry, Tom, were you asking, do you have a question? No.
So what you are doing when you split the users in two is somehow A/B testing.
Yes, it was an A/B test.
So to me, this is the ground truth. You really have the visual to completion after.
Not necessarily. I mean, basically, the data would highly, I mean, center around the hints being generated there, right?
So,
for example, I generate another different kind of hints. The data couldn't tell me whether my hints are actually taking good effect, right? Or even better than the hints that Daniel's features would generate, right? So that's what I'm talking about. Of course, there's no single ground truth, but at least we have some kind of like somewhat reasonable set of these useful hints.
But at the current time, I'm only thinking about hints as that I can get a machine to generate, which probably look very different than hints that I can get a human to generate. And there's a fairly reasonable assumption that the hints that we can get a human to generate are probably going to be better.
Right, but I'm thinking about more like grand challenge. Right? I mean, like that's the ground truth, and then human could do like this. How far can we get closer? Right? I mean, I think that's the kind of thing. Then you had community building, different people would jump in with their contribution of the solutions, right? Mm-hmm. So, but
that's a very reasonable way to think about the problem.
Yeah.
And did you measure the difference between the line-based hints and the other ones with such?
No, I did not. Partially because, I guess, sort of as you can see on this chart, the line-based hints are often not available. So I was sort of wary about having that as an option in the experiment because I was worried about people just never seeing them.
So in general, you give one line-based hint for 9 other hints, or what's the proportion between?
So, I mean, this is about, the line-based hints can be generated on about 20 to 30% of attempts that are not solutions. This is proportion of attempts that are not solutions, obviously. If the attempt is a solution, then the response is you won. And the other hints can be, and some hint at all, that is, I guess, can be generated on about 70 to 80% of the solutions. So basically another 40% 40 to 50%. And the line hint, the system prefers giving a line hint if it can. So.
Have you considered doing the hints on demand? So that it says, I have a hint available, but you have to actually click it to see it?
We did originally consider that UI, but it was vetoed as just being too onerous. I think that was actually the original UI I wrote, and it was just like, this just seems obnoxious. No one's ever going to.
It seemed like in that one graph that the people that were always getting the hints sometimes didn't want them, right?
Yes. This seems like a very reasonable assumption, and trying to work that into the UI is probably something worth considering. That it is known that in educational games, giving people hints constantly is not the right choice. But you need to have a UI where it actually works.
So like for coding duo, basically you have like two phases, right? Discovering the functionality or requirements, and the second one is implementing correctly the functionalities.
Yes.
My gut feeling is that for the hints that you are generating, they are more for the second phase. Is that hypothesis?
I would say that is definitely true of the line hints.
Okay.
I'm not convinced that's true of the recommendation hints. Especially in things like, as Judith had shown in her presentation, division is hard because integer division can create patterns that don't look like anything you expect to when you're reverse engineering. So if you get a hint saying, you know, you should consider a division operator, you'll be like, oh, duh, why didn't I think of that? I don't know if the people who won Code Hunt contests have anything to say on that. You didn't have any trouble with division operators.
Yeah, it'd be interesting to hear. Were there puzzles that you would have needed a hint on? Or?
Wouldn't be here. We wouldn't be here if there were, right? Sorry. Someone else have a...
Okay. Well, thank you very much, Daniel.
Thanks.